So you understood the concept of charge distribution, right? So there are three types of charge distributions. What are they? Linear, surface, and the volume charge distribution. So with the help of those charge distributions, what we are going to do is, right? So what we are going to do is understand this Gauss law. See, for example, let's say I have a system where it's a linear charge. So due to the linear charge distribution, if I'm interested to calculate the value of electric field, let's say at a distance r from the point P, okay, then see, if I need to use Coulomb's law, then what should I do? Will I be able to use Coulomb's law in the first place? Maybe I can if I'm able to break it into infinite number of point charges, right? So what I need to do is I need to take a small point charge dq, and due to this dq, what will I do? I will find the electric field due to this at this point, right, which is going to be dE. I'll find this value and then integrate it, which is a tedious process. Right, you can do it, right? You will get an answer, but it will be slightly difficult. So what has happened is, in order to solve this issue, right, of this extended charge and the concept of symmetry, there is an other law which is going to help us to solve the problems, and that is what this Gauss law is. So if we need to apply this Gauss law, see, it's very simple. Okay, if I ask you, if you look at a question, when are you going to apply Coulomb's law? Like, the question itself will give you a hint. Okay, this problem I can solve it using Coulomb's law. What does it state? First thing, it should speak about 2-point charges or more than 2-point charges, and if you know the distance of separation between them, you are clear that yes, I can solve this problem using Coulomb's law, right? Whereas, when will you know that, okay, I can think of Gauss law? Is a question, right? So Gauss law is a law which relates two important concepts. One is the total electric flux. So in the previous class I discussed about flux, no? So what is flux? Flux is the total number of field lines that are passing through a given area perpendicular to it, right? So if I know the flux that is getting generated due to a charge distribution, and if I know the total charge which is present within the closed surface, if I am able to relate these two concepts, then I can apply Gauss law. So what is the hint again? I come again. What is the hint? When will you know you need to apply Gauss law? Gauss law is the law that relates the flux through any closed surface and the net charge that is enclosed within the surface, right? So if I have the concept of electric flux and the total charge that is known to me, I can solve that problem using this law. Is that clear? So that is the first part. Okay, it relates, but how does it relate is what the statement is. So the statement says, if you know the total flux generated due to the electric field, right? So the total flux that is generated due to the electric field will be equal to 1 divided by epsilon naught. 1 divided by epsilon naught. What is epsilon naught? Is the permittivity of free space. 1 divided by epsilon naught times the charge that is present within the closed surface. So for you to define flux, what is that you need? You need a closed surface in the first place, right? So what are they saying? You can always relate the total flux that is coming out of or going into a closed surface is equal to 1 by epsilon naught times the total charge that is enclosed within the surface. So that's what the statement is. But how do I write it mathematically? So I need to convert the statement into a mathematical part. So phi stands for flux. So if I put a subscript E, then this will be equal to 1 divided by epsilon naught times the charge that is enclosed. ENC stands for enclosed. Okay, it's a subscript. So the electric flux is equal to 1 by epsilon naught times the charge enclosed by the Gaussian, by the closed surface. I'll tell the name of the closed surface, right? This is one point. Or this flux is there, no? You can write the flux in terms of electric field and areal vector. How do you write it? or you write E vector dot A vector is equal to 1 by epsilon naught times the charge enclosed by the Gaussian surface. That is one thing. And the next important thing is, not every time you will know the exact value of electric field and the exact value of aerial vector. Sometimes you will be able to know only the value of small dA, small aerial vector, that is dA. At that time, what you're supposed to do is, you will write it like this: E vector dot dA vector is equal to 1 by epsilon naught times the charge enclosed by the Gaussian surface. Listen to this carefully. This is only the flux through the small area dA, right? If I put an integral symbol like this and put a circle around this, you will call it as surface integral of E vector dot dA vector is 1 by epsilon naught times charge enclosed. So how do you read this as? You call it as surface integral. So surface integral of E vector dot dA vector is equal to 1 by epsilon naught times the charge enclosed by the Gaussian surface. Okay. So these are the three ways in which you can mathematically write, but there is a definition. Please make a note of it.